Section 3.1b, important interest formulas. We're going to start talking about in this section. These formulas you must know. You will not always be given these, so make sure you know these formulas, and even more importantly, you know how to use them in understanding what each of the variables represent. First formula is for n compoundings per year. Formula is the amount in the account is going to equal the principal amount invested times the quantity 1 plus the rate divided by n, all raised to the nt power. Second formula is for continuously compounding interest. Is the amount is going to be equal to the principal times e to the rt. Now the variables p, r, and t in both these formulas mean exactly the same thing. So you don't need to memorize two different sets of variables here. The amount at a certain time is a in our formulas. P is the principal amount invested. That means the initial amount put into the account. R is the interest rate. Don't forget that interest rates you need to change to a percent before you calculate with them. Or, I'm sorry, change to a decimal from the percent. T is time in years unless otherwise specified. In these formulas, T must be in years. In some other formulas that you may be given separately, it may say that time is months or something like that. Then make sure that you are plugging in the correct form of time that you are using. And N is the number of times the interest is compounded in a year. So you must know, for instance, if it says it's compounded monthly, you need to know that there are 12 months in a year. If it says it's compounded weekly, you need to know that there are 52 weeks in a year. If it is compounded daily, you need to know that there are 365 days in a year. So if you don't know those three things, make sure that you do, because that will not be a pretext into getting any of these questions incorrect. Okay, it will be assumed that you know how many months, days, and weeks are in a year. So looking at our first one here, $9,000 is invested at 8.5% compounded annually. Find the balance after 3 years. So the first thing you're going to need to do in all these problems is decide which formula you're going to use. In this case, we're going to use A equals P times 1 plus R over N to the NT power. The only time you would use A equals P times E to the RT is if it specifically says that the interest is compounded continuously. So now plug in what we know. We know that we're investing $9,000 at a rate of 8.5% is 0.085. It is compounded annually. If something happens annually, how many times per year does it happen? Just once. Raised to the NT power, we want to know the amount after 3 years in this case, so that's why we plug in 3. Go ahead and plug this into the calculator. Let's take a look at how to do that. Make sure that you are able to plug all this in one step. It is going to save you a lot of time if you can. So in this case, we have 9,000 times 1 plus, you have to be able to use parentheses well here, 0.085 divided by 1. Close that fraction, close the whole set of parentheses, raised to, and now here's where a lot of mistakes are going to be made. On this calculator, pops up into the exponent, you don't have to worry about this. If you have an older operating system and it doesn't pop up like that, you need to make sure that you are putting this 1 times 3 in parentheses so that it reads that as being the entire exponent. Hit enter. There's the amount that would be in the account after 3 years. Rounding here, remember our rule is to round to 3 decimals unless it does not make sense to do so in the context of the problem, as it would not in this case because we're talking about the dollar amount. We're only going to round to 2 decimal places. We have $11,495.60. $12,000 is invested at 9%. Find the balance after 5 years if interest is compounded quarterly. A equals P times 1 plus R over N to the NT power. Plug in everything we know. This time we're investing $12,000. Rate is 9%, 0.09. Compounded quarterly. If it's compounded quarterly, that means it's compounded 4 times in a year. Raised to the 4 times 5 power. Show one more time how to plug this type into the calculator. We have 12,000 times 1 plus 0.09. Don't forget your parentheses like I almost did. 0.09 divided by 4. Close that fraction. Close the big set of parentheses. Raised to the 4 times 5 power. We have $18,726.11. Go ahead and record that. $18,726.11. Now in B, what happens is we compound the interest continuously. Well, for one, we're going to switch formulas. This is the only time we will use this formula is when it's compounded continuously. We're still going to plug in everything the same way. We have $12,000 times E to the 0.09 times 5 power. Plug this into your calculator. 12,000 times E to the 0.09 times 5 power. $18,819.75 if we round to 2 decimal places. You can see if it's compounded continuously, we do end up with a little bit more money, almost $100 more in the account after 5 years. The more times that interest is compounded within a year, the more money that you are going to earn on the money that you are investing. Number 9, why is the mass of a radioactive element whose half-life is 25 years? After T years, the mass in grams is given by this formula. Y equals 10 times 1/2 to the T over 25 power. A couple of questions we're going to be asked here. The first one, what is the initial mass? Well, if we're talking about the initial mass or the starting mass, how much time has gone by? Well, if it's initial, that means no time has gone by. So we're simply going to take this formula and we're going to plug in 0 for T. We know anything to the 0 power is 1, so 1/2 to the 0 power is 1. We have 10 times 1, which means then that we are starting with 10 grams of this substance. How much of the element is left after 80 years? So now 80 years have gone by. We want to know how much of that 10 grams is going to be left. Y equals 10 times 1/2 to the 80 over 25 power. Plug that into your calculator. Now we're back to rounding to 3 decimals. So 1.00 or 1.088 grams would be left after 80 years. Last one here, number 10. Number of fruit flies in a population after T hours is given by Q of T equals 20 times E to the 0.03 T power. What is the initial population then of fruit flies? Well, once again, if we're talking about an initial population, no time has gone by. So we're finding Q of 0. So we're plugging 0 in for T equals 20 times E to the 0.03 times 0 power. So now simplify this. You shouldn't need to go to the calculator here. E to the 0 power is 1. So we have 20 times 1, which means that we are starting with 20 flies in this population. What is the population after 72 hours? Well, after 72 hours means that we're going to plug in 72 for t. Population after 72 hours is going to be given by 20 times e to the 0.03 times 72. Plug that into your calculator. 20 times e to the 0.03 times 72. And now think about how we need to round here. Our rounding is talking about a population of flies. So where does it make sense to round to? A whole number, because we can't have a fractional part of a fly. About 173 flies after 72 hours. Last one, what is the population after 10 days? Notice how our variable t is defined here. It's defined in hours, so we can't plug in 10 here. We need to take 10 times 24. There are 240 hours in 10 days. So now we're finding Q of 240, which is going to be 20 times e to the 0.03 times 240. Plug that into your calculator. Q of 240 is 26,788 flies.